Hello everyone. I hope you have enjoyed the last session of the unit number 1 about software engineering and project management. We had talked about software, its applications, its domains. Now we are going to talk about the myths in the software and some details about software engineering. So let's just have a quick look at what we have learned. So what it is? What is a software? It is the product that software engineers design and build. It encompasses programs that executes within a computer of any size and architecture. So who is going to do it? It is software engineers who are going to build and support the software. Why it is important? Because it is affecting our everyday life. It has become pervasive in our day-to-day life, our culture and our everyday activity. So just have an example. So without these all softwares available, it wouldn't have been possible for me to interact with you being at home. I hope this background gives you the feeling of you are learning in college. So alright, let's continue. What are the steps which we are going to take while building the software? So what we have to do is we have to apply the process that is going to give us the high quality software which is going to meet the needs of who are going to use it. Now what is the work product at the end once we follow the steps? So from programmers point of view, they are going to get programs, they are going to get the data, they are going to have the documents which are going to describe how the software should be used and all the details. And from users point of view, they are going to get something which is going to change their world, which is going to make their lives better. So this is all about software. Now we can talk about software engineering, which is the purpose of learning. So there are two definitions. The first one is the seminal definition. It says software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. So let's just see what this definition says. It says we are going to establish and use sound engineering principles. So one of the principles is you have to understand the problem before you build it. So this is the principle we have to follow. Suppose while working you find out some new thing, then you can add it to the existing principle and let your team use it. So we are going to establish while we are doing it, and we are going to use the existing things which are there. Now what is the purpose? The purpose is to obtain economically software which fits our economical values. Okay, and what is the expectation from that software? That it should be reliable. It should not happen that in the morning it was working fine and now it is not working. This should not happen. And it works efficiently on real machines. So which are real machines? Right now it is computer. Maybe tomorrow it is mobile phone. Maybe tomorrow it is a virtual desktop which I have. So it should work wherever it is intended to work. Okay. And now we have got the another definition which is from IEEE. So it says software engineering is the application of systematic, disciplined, quantifiable approach to the development, operation and maintenance of software. That is application of engineering to software. So even if it is systematic, disciplined and quantifiable, it should not be burdened to some other team. If it is disciplined for me, it may not be disciplined for somebody else. So what we want is, along with these three criteria, it should also have one condition as adaptability. So whatever procedures we are going to set, that should be adaptable as per the team's needs. And what we are going to get is, we want to use these all approaches in having development of software, operation of software and maintenance of software. Here I would like to tell you one thing is, you must be knowing there are many software industries who are building the software, but there are many more who are focusing on maintaining the existing softwares which are already built. Okay, so maintenance is important part of softwares. So we have learned these two definitions. I hope you write them once. Okay, so software engineering is said to be a layered technology. So it encompasses a process, methods for managing and engineering software and tools. So if you observe the diagram, the base layer is of quality, then process models, methods and tools. We are going to see them one by one. Any engineering approach must rest on organizational commitment to quality, which fosters a continuous process improvement culture. Okay, so we want that at the base of it, it is the quality which matters to any organization, any work product which they are building. So if the base is quality, then of course the work product which we are going to get would be nicer one. So then is the process layer, which is the foundation which defines a framework with activities for effective delivery of software engineering technology. So establish the context where products, that is model, data, report and forms are produced, milestones are established, quality is ensured and change is managed. So what is this milestone word here? So you must have observed the milestones which are there when we travel. So it gives us the idea of how much closer we are towards our destination. So in software industry also, milestones are there which will give us the assessment of the progress which we have achieved. Okay. Then we are having methods which provide technical details on how to build the software. It encompasses many tasks including communication, requirement analysis, design modeling, program construction, testing and support. Don't worry, we are going to see these all in detail very soon. And at the end, there are tools which provide automated or semi-automated support for the process and methods. So our purpose of coming to college was learning, alright. So this PowerPoint presentation is a tool which we are using so that the contents which I have created can be shared with you. So there are same set of tools which are available for building software. So any language editor can be used as a tool, which I am using to create a simple program, and that program is nothing but a software, alright. Now we are going to talk about myths. Now you would say there are other topics also in the syllabus like software process and software engineering practice. Why I didn't go there first? You will understand the reason very soon. Now we are going to talk about software development myths. So what are these myths? These are erroneous beliefs about software and the process that is used to build it. These are believable because they often have elements of truth, but invariably they lead to bad decisions. Therefore, we should insist on reality as we navigate our way through software engineering. Today, most knowledgeable software engineering professionals also recognize these myths because these myths are misleading, which has caused serious problems for managers as well as practitioners. So we are going to see these myths. These are divided into three categories. The first one is management myths, then we have got customers myths, and then we have got practitioners myths. We are going to talk about them one by one. So management myths, the first myth says managers think we already have a book that is full of standards and procedures for building software. Won't that provide my people with everything they need to know? So it is like telling you students to come in college and go to library and have the set of books and complete your engineering. So how that is possible? So the book which we are specifying, whether it is really used, whether the software engineers are really aware of its existence, does it reflect modern software engineering practice, is it complete, is it adaptable, it is streamlined to improve time to delivery while still maintaining a focus on quality. So do you think just the book is going to solve the purpose? The answer is no. So the reality is only book is not going to solve the purpose. Okay. The second myth says if we get behind schedule, we can add more programmers and catch up. But in reality what happens is it is not a mechanical process like manufacturing. Okay. So at first we think that if we add more people, then their job is to just produce the same kind of product which other team members are doing, but that is not the case. When we add new people, we have to spend some time educating them. Then that is how what happens is the people who were actually building some code are now wasting their time in training those people, other people. So this is how even if we add people, it is not going to affect. We can add people, but that has to be done in a very planned and well coordinated manner. The third myth says, if I decide to outsource the software project to a third party, I can just relax and let that firm build it. So if an organization does not understand how to manage and control software projects internally, it will invariably struggle when it outsources software project. So what is this outsourcing? Outsourcing is a piece of work which was assigned to me that I am giving to somebody else to complete it. So if I say that I am giving some portion of program to write it to you on behalf of me, then I just have to relax. So that is not going to happen. If I do not know what I was expecting from that short piece of code, then how I'm going to evaluate it? So just outsourcing it and relaxing is not going to help. This is what the reality is. Now we are going to talk about customer myths. The first myth is, customer think that a general statement of objective is sufficient to begin writing programs. They can fill in the details later. It is like saying, okay, you bring me a chair. Chair? Okay, bringing a chair. But if we do not specify what size requirement we have, what color requirement we have, and what other financial details which we need to add, then that is not going to help the person who is going to bring it. So reality is, although a comprehensive and stable statement of requirement is not always possible, an ambiguous statement of objective can create disasters. So unambiguous requirements are developed only through effective and continuous communication between customer and developer. So customers also should realize this, that they have to keep on interacting with the team so as to get what they really need. The second myth is, software requirements continually change, but change can be easily accommodated because software is flexible. Do you remember case of Yashwant? He was telling when they were about to deliver the product, customer had demanded for some change request. So it is true that software requirements change, but the impact of change varies with the time at which it is introduced. When requirements changes are requested early, the cost impact is relatively small. However, as the time passes, the cost impact grows rapidly. So you can consider any simple example. You are preparing a recipe, and in between, if I tell you to change some ingredient, then if you have not started it preparing, then it is all right. But once you have prepared it half, and then if I tell you to add something new, then you know what is going to happen. So customers should realize about this. Then we are going to talk about practitioners myths. Practitioners are the people who are actually preparing the software. So they think once we write the program and get it to work, our job is done. But the reality is, someone once said that the sooner you begin writing code, the longer it will take you to get it done. So industry data indicate that between 60 to 80% of all effort taken on software will be expanded after it is delivered to the customer for the first time. So just writing it is not the purpose. Okay, after that actual work begins. So the next myth is from practitioner's side. They think until I get the program running, I have no way of assessing its quality. So it is like writing a very simple C program, and then you think the moment I press Ctrl F9, then only I'll be able to understand what errors are there. But do you think there is some other mechanism? Yes, there is. You just can go through that piece of code which you have created. You just have to read it. You have to cross verify whether according to the program statement which was given to you, you have added sufficient statements, variables or not. So one of the most effective software quality assurance mechanisms can be applied from the inception, that is beginning of a project, that is technical review. Software reviews are a quality filter that have been found to be more effective than testing for finding software defects. So here defect means the problems which are present in the software, and review is whatever work you have created, you have to just read it. It may be either you, the creator, who is going to read it, or you may give it to somebody else to read it so that they find out problems present in it. So next time before you actually compile your program, you have to remember, instead of seeing those 20-25 errors, you can just have actual output screen if you go through your program once. Then the next myth is the only deliverable work product for a successful project is the working program. Okay, so this is the myth which practitioners have. A working program is only one part of a software configuration that includes many elements. We have already seen the definition of software, if you remember it. So we had said that software is instructions. So that is what, as a programmer, we are going to create. But along with that, it needs to have the justification of data structures as well as the documentation. So a variety of work products, that is models, documents, plan, these all provide a foundation for successful engineering and, more important, guidance for software support. If you leave the team, if somebody else joins, then also for them they are useful, and of course it is useful for having a better quality software. The next myth is, from practitioners' point of view, they think software engineering will make us create voluminous and unnecessary documentation and will invariably slow us down. So we need to understand that software engineering is not about creating documents, it is about creating quality products. Better quality leads to reduced rework, and reduced rework results in faster delivery times. So here we will make sure that while doing each of the work, we have to keep track of what we have done. So in industry, they have got this mechanism where they have to create a daily report of what work they have done. So, and also we have to always add comments to what work we have created. This is good programmers practice. They have to write comments when they are writing the program. So these two principles are added by software engineering. While writing the program, if we feel burden of writing comments, then to next generation, that is the next set of people who are going to use that product, it might not be very useful. So this was all about the myths which we have discussed. I hope you remember these myths very well. So from exam point of view, you may be asked on any of the myths, either customer myths, practitioner myth, or management myths, and you have to provide the myth as well as the reality which is actually there present corresponding to that myth. So this is the number of pages which I have referred, and see you in the next class. Thank you so much.